Hello again, class. So today we'll be looking at logarithm rules, and the first thing you'll notice is a table in front of you, and over here you can see all the various log rules out there. And what basically you have to remember is this second part over here, not this one over here. I mean, this is a more generic one. But what the UOL exams, as far as the UOL exams are concerned, they care about natural logarithm, which is ln. So when it comes to log, you'll use ln instead of the usual log form. Um, so what is ln? ln is basically log with the base of e, right? Log with the base of e. Let's say log base of e of x, any variable x, that is the same as ln of x, right? Where ln is natural logarithm. So for your UL syllabus, you will only be dealing with natural logarithms. So however, it's all the rules of natural logarithm are coming from this more generic one over here. So for your convenience, I have listed both out for you. You only need to remember this part, but you're very free to go through the generic one as well and see how it differs between this and the natural logarithms. Okay, so the first two over here, quite easy, straightforward. We have product rule and quotient rule, where if you have log of x times y, it's equal to x plus log y. So please be careful. You should not confuse log of x times y with, I mean, some people came to me saying that, oh, we have ln now. So if we have ln x multiplied by ln y, would that be equal to ln x plus y? And obviously, if you check the first rule, there is no such mention of this, so this is not valid, right? Whatever, only thing that's valid is log of x times y. Log of x times y is equal to log of x plus log of y. Only this is valid. We don't have any formula for log of x multiplied by log of y. This is absolutely wrong. Okay. So again, please be careful of these small caveats. And then also the second one is similar. Log of x by y is log x minus log y. Now I won't go through, presentation karaoke of all these rules. So I'll let you go through all these things. And again, if you have any doubts on any of these, do reach out to me. But I think this table is a very good, like, concise uh, way to go through all the different log rules out there. Okay, few things which are really important. I think these two over here are very special case usage of logs and log rules, so you might not need to worry about those two. However, things like this one, for example, this rule over here, log of negative number, it's not valid. It's not possible. You cannot have a negative number. Similarly, you cannot have a zero. So log of zero is undefined, just like how the negative number is. Okay. You also need to remember that log of 1 is always 0, right? And here, so this one is again important. So the generic rule tells me that log of b, if I have a base of b, is equal to 1. And the same thing applies when it comes to natural logarithms. So log of e, because I have a base for natural logarithm, let's say ln of x, as I said, is equal to log of base e x, right? So similarly, ln of e is equal to log base e of e. And if I compare this with this generic rule, then yeah, that makes sense. Log of base b with b of b is equal to 1. So hence you get this part over here. Log of ln of e is equal to 1. Similarly, ln of e to the power x is equal to x. Now why is that? Because log ln of e to the power x, we can write that as x times ln of e. right? Using which rule is it? This one over here, the third rule. Log of x to the power y is y times log of x, right? Similarly, log of e to the power x would be equal to x times log of e. And we already know that log of e is equal to 1. So this becomes x times 1, which is x. All right. So on, if you have log of e to the power 4y, that will become 4y, and log of e to the power whatever is the function, it will be just that function, and so on, right? And one last thing is logarithm of infinity is infinity, basically. So if your x tends to infinity, then log of x will also tend to infinity. So these are few things you need to remember. And yeah, some more things over here. This part is if I have b to the power y is equal to x, then its log form is this. Log of b, log base b of x is equal to y. Now let's look at this with the help of an example. Let's say I have a question, and the question is, what is log base 2 16 equal to, right? What is this equal to? So if I compare this with equation number 2, if I compare this with equation 2, my b is equal to 2, right? X is equal, x is equal to 16. Why won't it let me write? X is equal to 16, right? And y is unknown. Y is unknown. We need to find out y, right? So now we got b, x, and y. Let's put all these in equation 1. So I have b, that is 2, 2 to the power y we don't know, x we do know is 16, right? Now if we want to find y, we know that y is the power of 2, the exponent of 2. So if I want to compare left hand side and right hand side, I want to convert the 16 as something which is like a power of 2. So let's say we know that 16 is 2 to the power 4, right? Okay. Now, because we have 2 as the common base in both left hand side and right hand side, clearly y then is equal to 4 for left hand side and right hand side to be equal. So this is basically the same as writing log base 2 of 16 is therefore equal to 4. Okay. So this number 1 and number 2 is another thing you need to remember, is if I have an exponent form, how do I convert to log form and vice versa? So these are few things, logarithms, which will be useful for your exam point of view. Right, let's move to exponents and power. This is even easier, and I won't go through it in further details. We have already covered these. So some basic rules again: x times a times x times, x to the power a times x to the power b is x to the power a plus b, and the same for quotient, and then you have product, right? However, what I want to emphasize on a lot is this thing over here. A common mistake which people do is if there is x plus y to the power a, they usually write that as, they open the bracket and they say that it's x to the power a plus y to the power a. This is absolutely wrong. So please do not make this mistake, right? The answer in this case is we don't know. It depends. It depends. If a is 2, if a is equal to 2, then we have a formula for x plus y whole square, right? We have a formula which tells us it's x square plus y square plus 2xy. So if you were to write this, x plus y to the power 2 is equal to x square plus y square, that's wrong because we have plus 2xy as well, right? So this formula is like, this thing is a common error, and do refrain from it. Similarly, if a is equal to 3, we have another formula for that, right? And so on. So do refrain from these kind of mistakes. Now let's see if there is anything else. suppose I have p plus q to the power 7, right, upon p minus q uh, times p plus q to the power 4, right? Now if you have to simplify this, so what can we do? So the first thing we need to see is, to simplify this, we have to see what are the terms that are common in both numerator and denominator. Clearly, it's p plus q. P plus q in the numerator and then p plus q in the denominator, right? So what we can do is we can take that common term p plus q, right? And according to this second rule over here, if I have a quotient of not a quotient but in division form, then I have p plus q, the power will be 7, right? The power is 7 in the numerator and the power is 4 in the denominator, so it will be 7 minus 4, right? And p minus q, I don't have any p minus q in the numerator, so that will just stay as it is. It will be p minus q. The p plus q in the denominator, it went up to the numerator with this minus 4 sign. Okay. Another way you can think of it is, this is nothing but p plus q to the power 7, right? Oh, I think there should be another rule for exponents, that is x to the power a is basically equal to 1 upon x to the power minus a. So if you reciprocate the power, if you reciprocate the number, sorry, if you reciprocate the number, in this case the fraction, then the power just gets a negative sign. Okay, so right, okay, so now we use this same rule over here. So we have p plus q to the power 7, which is the numerator. The denominator is p minus q. And now if I want to move this p plus q to the power 4 from the denominator to the numerator, that will be p plus q to the power, this 4 will become minus 4, right? And again, now you have product. So in the case of product, it's where did my cursor go? In the case of product, it's a plus b, right? So I have p plus q, and a plus b will be, basically a is 7 and b is minus 4. So 7 minus 4, right, upon p minus q. So it clearly depends on whichever you're more comfortable with. Is it this one or this one? It's just different way of visualizing the same steps for solutions, right? So what you have now is p plus q, 7 minus 4 is 3 upon p minus q, right? And this will also give you the same answer. 7 minus 4 is 3 and upon p minus q. So please do bear in mind, all the solutions do stem from this, not this one, sorry, that's the error. Don't do this, don't do this. So all the solution basically stems from these three and this one over here, these four rules of exponent and power. And the same for logs. I think is a bit more for you to absorb, but everything's there in this table. And what I'll be doing is, probably I'll share this table with all of you, so that is convenient. So well, happy practicing, and I shall see you in the next lecture very soon. Take care.